All right, guys, we're going to start example 1, which is very similar to what we did the other day, only bigger and badder. Involves clearing fractions, which it's important that you are very slow, step by step. Take your time because it is super easy to make mistakes. It's so easy to do. So what you have to do in order to solve this type of problem is clear the fractions. And in order to clear the fractions, you have to identify what the common denominator would be of all of this. Now, I just want to tell you that if I, first off, make this fraction a negative, then that means one or the other has changed. That makes this one z minus 3. And that's going to come in handy later. Okay? That is going to come in handy later. So this is a difference of squares. Z plus 3, z minus 3 is what that would factor to. And we can already see what that is. So if you notice, we've got z plus 3, z minus 3, and z minus 3 as our available denominators. The LCD of all of that is going to be this. Z plus 3, z minus 3. And don't forget about that negative. Z plus 3, z minus 3. Z plus 3, z minus 3. All of that we're going to work through. We're going to cancel our z minus 3. We're going to cancel this entire thing. And we're going to cancel z plus 3, leaving us with the product of negative z plus 3, z plus 3. Negative z plus 3, z plus 3. Everything canceled there, plus 11z plus 3 equals, all we're left with here is z minus 3, and I'm going to flip the order on that so that it looks 5z plus 1. I don't like it when the z is at the end. I don't like that. So this is z squared plus 6z plus 9. Making it all negative means negative z squared minus 6z minus 9. Okay? If you just simply a squared plus 2ab plus b squared, you get z squared plus 6z plus 9. This negative causes everything to flip. 11z plus 3. And now let's do this mess. Negative 5z squared first, outside plus z, inside plus 15z plus 3. Okay, let's combine everything that we can. Negative z squared, negative 6, positive 11, positive 5z, negative 9, positive 3, negative 6. Over here we have negative 5z squared plus 16z plus 3. We're going to maneuver all of this to the left, factor, and solve. Plus 5z squared minus 16z minus 3. Plus 5z squared minus 16z minus 3. That should be a negative. Sorry. That should be a negative. That should be a positive. My goodness. All right. Here we go. So I now have 4z squared minus 11z minus 3 equals 0. Yeah. 4z squared minus 11z minus 3. Now, for sake of time, I'm not going to go through the steps to factor because you've all been taught that. But the factor is 4z plus 1 and z minus 3 equals 0. which means z is a negative 1/4, subtract 1 divided by 4, or z is 3. Now, 3 cannot possibly work because if you insert 3 here, you get a 0 in your denominator. You get a 0 in your denominator. Here you don't, but you've already excluded it from the set because it can't possibly work. It zeroes out the denominator. Okay? That being said, 1/4 is the only viable solution that you have available. So, let's move on to another example. See if I can get through one more. So, 10 over x squared minus 4 is equal to 1 minus 1 over x plus 2. You may already see that this is x plus 2x minus 2, which means the LCD of all of this is x plus 2x minus 2. Okay, so each piece gets multiplied by x plus 2x minus 2, which in this case is going to cancel completely, leaving me with just a fancy little 10. X plus 2, x minus 2, x plus 2, x minus 2. Boom, boom, 10 is equal to, that's x squared minus 4 minus x minus 2 times 1, which is x minus 2. Notice I threw that in parentheses. I did that for a reason. If you do not recall those parentheses right there, you can easily neglect to carry that negative over both of the pieces that are being subtracted. So now what you have, incidentally, is x squared minus 4 minus x plus 2 is equal to 10. To clean this up a little bit, x squared minus x, negative 4 and positive 2, minus 2 is equal to 10. Subtract your 10 over and you now have 0 being equal to x squared minus x minus 12. 4 and 3, I'm thinking, factoring. So x minus 4, x plus 3. Looks like that'll work. X minus 4, x minus 3. So that means x is 4 or x is negative 3 once you solve those both for 0. Now, do either of these zero out the denominator? No. 16 minus 4 is still good. 4 plus 2 is still okay. Negative 3 in the same way does not zero out the denominator. That being said, it would behoove you to test both the 4 and the negative 3 in the original equation, which was 10 over x squared minus 4 equals 1 minus 1 over x plus 2, right? That was our original equation. Test both of those things because there are times, I'm sorry to say, when you will have one of these solutions not actually check out in the original equation. And the name for that is an extraneous root, okay? Extraneous root. And at the bottom of page 247, it says always, always check to verify that you have a correct answer. For sake of time, I'm going to tell you that when I plug these in and check, they are both correct. So that both satisfies your equation, and that is a complete solution set. So both of those are correct. So today's assignment for you is going to be pages 249, 250, 2 through 22, evens only, please. And they start out pretty simple, so you should be good. I showed you the hard ones. Have a great day.